How are you all doing? I am back here in California now, and I wanted to return to filming, and I've gotten kind of situated over here to the best of my ability before I just needed to get back to filming. And I wanted to start this video off actually with telling you a little bit about an individual and a entity that I heard about recently. I got an email from one Caden Wynn, and he founded last summer a 501c3, which is a nonprofit organization or a type of nonprofit called Empower and Elevate. And it provides free mentorships and internship opportunities to high school students of disadvantaged backgrounds. Our mentors give personalized advice to students on how to reach their career goals based on their own experience. And so they're partnered with Pleasanton Partnerships in Education and Pleasanton Unified School District's Foster Kinship and Support Program to provide mentorships to foster kids and kids of underrepresented backgrounds in our own community. Well, when he reached out to me to ask if I could help him out in the future or work with him in some capacity, some of you probably don't, actually none of you probably know this. I actually spent time in foster care as a kid. It was not, it was, a few months or a few weeks, a little bit over a month. And so I kind of heard about this and I thought, man, this sounds fantastic. I don't know how I can help her in what capacity, but he recently emailed me with an update about a upcoming event. The career night is going to be held on Sunday, March 27th. And I met him on Zoom and talked with him about it. You can see his team here. I'm going to click Our Team. And it's got the people who were part of it that helped organize and found this and develop it and all of that. Caden's over here on the left. I can just say he was a very humble individual who I got the sense was very genuine. He really does have a heart to just help other people. And I thought that's amazing. And so if you know anybody who would be interested in this, if you are a parent or an adult and you know of maybe your school might know some people who could participate in this, it's going to be an online event. If I click the Career Night link right here on his website, it will open up the second page for it where you can sign up. These links will both be in the description of this video as well. It's March 27th. It's a Sunday from 7 to 8:15 p.m. As you can see, there will be a virtual meeting. Accomplished career professionals will share their experience with middle and high school students. They will have breakout rooms for each speaker, and students will be able to choose which room they want to go into. Career Night will provide a wonderful opportunity for students to get advice and learn from professionals in a variety of career fields, mostly STEM fields. If it says there our speakers are experienced career professionals with advanced degrees in a variety of disciplines, including software, electrical, mechanical engineering, artificial machine learning, aviation, all kinds of things like that. There's going to be an event prize raffle. And so if you know somebody who would like to participate, or maybe you would like to participate if you're from one of those disadvantaged backgrounds, I think this is awesome. I think you should definitely do it. There's me. I'm a sponsor down there, apparently. And so, check it out if you get a chance, or spread this message to other people. If you have a channel, if you could tell them about this, I think this is awesome. This is a high school student working to help his community, and not just the local community, but the world community that we're all part of. I don't know what else I can say about it. It's amazing, and I hope that you are all thinking about ways that you can have an impact on your communities as well, whatever that might look like. So now what I want to get to is the mathematical intuition, how to build it, and I'm going to take this example from a recent class I had going through Volume 1. Again, as I'm going to state in all my videos as much as possible, here is the actual Volume 1 text that I own, the original time that I bought it, and, it's here. So I have this online copy, but I'm not going to, recommend that you use it illegally. If you have access to an online copy, you should probably have the one you paid for, or at least buy the book first before you use that. And I say this for one reason. This company is amazing. If you read the opening thing, and I always try to point this out, you probably can't see it, but my blur's blocking it. Right here, there's going to be this statement here by Richard, and it's a dedication page. It says, "For my desert flower Vanessa, told you we'd make it there eventually." I mean, it's heartwarming, of course, because it's to his wife. And, you have to understand that these kinds of things, when they take place, when they happen, required immense amount of sacrifice of time, often with no pay. And you gotta understand that probably puts stress on various relationships that an individual has. And so there is so much that went on behind the scenes to provide us with this great learning material that we can now benefit from. The least we can do is compensate the effort that they made, the sacrifice they made to get us to where we're at in the math community today, which is an abundance of resources that are available primarily from the art of problem solving, but now there's many other sources as well. So I recommend, if you have been using a PDF, that you buy the book as well to show your support. If you can't do that now, consider getting one from the library, or consider asking your parents to help, or doing odd jobs or things like that. No judgment. It's just trying to support what I think is good. So let's get to this example here. This is from chapter 11 of the volume 1 book. And it's, again, if you don't have enough time to prepare for the AMC and there's only one book that you can do, this should be it. It's going to give you blanket coverage of many concepts. It's not going to go in depth, not great depth, but you're going to get a lot of different topics covered at a decent level to where it's going to expose you to the ideas and concepts that you're going to need on the test. Is it going to get you every single one of them? No. If you want to explore the other topics in depth, like counting and probability, or number theory, or geometry, or algebra, then use those intro books as well. But this is the one book, if you don't have time to do any others, that you should definitely do. But how do you go through these books? Right? How are you doing it? Some people, I say, I just do the problems at the end of the chapter. I think you're missing out on a big part of the content. And I think you're also missing out on building the mathematical intuition that you're going to need on the test when it's not going to match the exact way the question was asked before. And so I want to give you an example of what that looks like, and I call this actively reading. When you read a book like this, it's not pleasure reading. I mean, it is kind of enjoyable. Let's not, say that, but it's not like, Harry Potter or some fictional series that you're reading where you're having fun reading the series. Okay? It's going to be something where you're actively engaged in the process of reading, and you're trying to learn what the writer is trying to tell you. It's a communication portal they've opened to you. Your job is to understand everything they're trying to tell you, but let's look at what it means to actively read. So I want to give an example here. I'm going to pull this out on a separate one. Here we go. And it worked perfectly. Okay, so I'm going to use... it's got me in the background over here because it screenshotted that one. That's funny. I wonder if I can move this camera over on top of that. No, that's not good. Okay, well, I don't know how that's going to work. But it's just funny. I'm sorry, that's great. I got to cover my face up. It's creeping me out. So anyhow, this formula right here. I don't have annotate on. I want this back on. Let's do that. There we go. This formula. I usually write it as half AB sine of C. I do not recommend that you memorize formulas according to their letters, unknowns, variables, whatever. Memorize them as their conceptual connection. What this would mean is that if you had a triangle of any size and you have an angle, let's say theta right here, and you knew, say, this was 7 and 12. Theta is a Greek letter. It's like a 0 with a slash going this way, Theta. And the way you want to think of it is it's half the product of the sides times the sine of the angle between those sides. Okay? It's an alternate way of finding a triangle's area. If you haven't learned trig yet, hey, there's time to do that. But for now, just understand SIN is not sin, it's sine with an E. So I want to take this formula here. I'm not going to go through the proof of it. I just want you to memorize it. Memorize it as, and put it in your small notebook if you have one going, half the product of two sides times the sine of the angle between them. Okay? In this case, the C would be theta instead of C. Because if you're dependent upon letters, if they change the letters, you're going to have difficulty, right? If I give you one and I want you to find it with B and I don't tell you angle C, are you going to get confused? Better to understand the conceptual connection for this area. There's a bunch more area formulas as well. I'm not going to get into all of them. But how could we learn from that? What is there to learn from that? Let's go back now, and I want to go to chapter 12. And chapter 12 is about quadrilaterals, and you'll scroll through, you'll read about trapezoids, and that you should read all of this in depth. That's not my point right now, though. I want to get to parallelograms here, and more specifically a certain page, and I kind of want to show you what it looks like when you're reading actively, okay? So here's it right here. You see this right here. You get to page 121 in the volume 1 text. Another formula for the area of a parallelogram is the product of any two adjacent sides and the sine of the angle between them. Now you see this right here. You see them state it. Let's go ahead and do this again with the cool button trick. And boom, we get another one over here. Let's make it bigger. Can I write on the screen? Yes, I can. All right. So down here, right, you get the formula. And they like to use brackets for area. Brackets means area. Okay. So down here, it's the area of ABCD, which we can assume is a parallelogram. Now, what is this? It's AB times BC times the sine of B. Let's just use one like this one up here. That's nice and made already for us. We can look at that instead of drawing our own. AB would be this side. BC would be this side. The sine of B is the angle in between. And we might be thinking right now, hey, that's kind of similar to that area formula we learned last chapter, half AB sine of C. Now is where you start asking yourself the questions. Do not wait for the teacher to ask you the question. The naturally inquisitive student will perceive so much more than those who require the teacher to prompt them. That doesn't mean that the teacher prompting you is bad. But if you want to become a solid thinking, critical thinking, creative thinking student, start asking the questions yourself and start trying to find the answers. Why does this look like this? Why do they look so similar? Well, AB is a side, BC is a side. Let's see if we could explore this. Don't wait for someone to tell you. Explore. The best problem solvers are explorers. If you're not exploring the content that you're learning, you're not even getting anything out of it. Okay, let's connect A to C here. Notice that we get a triangle ABC. That triangle, if I'm going to call this side A, let's call this side, I don't know, I guess we can't do that, D for now. Little a, little d, okay. Then the area of that one triangle would be half little a times little d times the sine of the included angle. Okay, but in a parallelogram, you've got two congruent triangles, so I could just double that. Now the 2.5 cancel. The AB is the side I marked A, the BC is the side I marked D, and then sine of angle B is the angle in between them. Now we see where it came from. Okay, so now that we've done that, we're going to go back and scroll a little bit more with our eyes, if you had the book or the on-screen one. Let's see what it says. Oh, look at this. Can you prove this relationship by drawing a diagonal to divide the parallelogram into what we just did, basically? This is a lot like when you're actually solving problems on the test. A lot of times, at least on the simpler questions, you can guess where they're going with something, and you will generate some new piece of information without being asked for it, and then go read the end of the question, and that new piece of information is exactly what they're asking for. Okay, that should be kind of how things go a lot of the time. Not always. You can't always, anticipate a question that's going to be asked, but you get a feel for it after a while. Just as you're reading this, you shouldn't have to wait for them to ask you before you're curious, hey, could I prove that? I wonder how they would do that. Right? Don't passively read. Actively read. Let's go farther. You can see here, as shown at the left, the diagonals of a parallelogram bisect each other. Did you prove this fact like we suggested? If not, try to now. We'll assume it's already been proven for the sake of this video because it's not the main thing I want to get to. Letting the lengths of these diagonals be D1 and D2 and the angle between them be theta, we have yet another formula. Okay, so let me just do this real quick. Actually, I'll scroll down to the formula so we can get that in this next part of the clip too. Okay. Can I write right now? I can. All right. I'm trying out this technology and I'm not quite sure how it all plays together when I'm filming. So yeah, that's why I'm asking that kind of question. So you can see over here, the whole diagonal, this right here, that could be D1. and the other diagonal could be D2. And notice that the marking on the diagonal, the two little hash marks, here and here, indicate that it's equal on those sides, meaning it's been bisected, right? That's what it means by the diagonals bisect each other. They meet at their midpoint. So each one, that E is the midpoint of both diagonals. Okay. So now they're saying there's another formula for the area of the parallelogram, which apparently is that it's equal to half the product of the diagonals times the sine of the angle in the middle. Interesting. So before we read on, which is what you should always be doing, you should always be pausing your reading and trying to figure out how this works, because my question would be, well, wait, what about this theta, the other angle? How do we know which central angle to make theta? And that's a great question. Again, if you need someone else to explain it to you, you're going to struggle to qualify for Amy. You need to start trying to ask yourself, and then it might not come to you immediately. You might have to explore it a little bit. So I'm going to, in this video, assume a certain basic understanding of trig values. This right here is going to be 180 minus theta, that angle. So what if I had made it a sine of that angle instead? Well, if we do sine of theta, you can demonstrate using trig identities that this is equivalent to sine of 180 minus theta. For instance, the sine of 30 will equal the sine of 150. If you've done any quadrant work with trig stuff, you know that 30 is over here, and the sine of 30 is going to be 1/2, and over here, the sine value will be 1/2 as well. When this angle here is 30 degrees, it makes this angle here 150. I'm not going to prove to you all of these identities right now. More so, I'm again operating with the assumption in this video that you know a little bit about this, and so now you can try to find it. If you don't know how this is true, try to demonstrate it. There's also a sum and difference formula for sine and cosine. For sine, it looks like this. If I do A minus B, it is SCCS, so sine A cos B, that's the SC. Then it's the same sine, it goes here, and then it's CS cos A sine B. So with this one over here, if I did sine of 180 minus theta, I would get sine of 180 times the cosine of theta. Note the negative sign doesn't need to go, although it wouldn't actually affect us in this problem. You knew that already. We don't need it because the minus is part of the formula. The b is just the theta. Okay? And then it's minus the cosine of 180 and then the sine of theta. Well, cosine of 180 is -1. So this is minus -1, which is plus sine of theta. What about sine of 180? Sine of 180 is 0, making this entire expression 0. And so you have 0 plus sine of theta, and there we've just proven, once you knew this trig identity, that these two are in fact equal. And so now you don't have to worry when you're writing this formula into your small notebook, which one do I call theta? It doesn't matter. Either one. It will work out the same way every time. Okay? So, now, do we need to prove this? How would we prove that this is true as well? How could it be that it's half diagonal 1 times diagonal 2? I'm going to make a new screen of this so we can work with that now, because I want to try to improve it. Let's get rid of this one too, and let's do another one of these and bring it back. Look, a brand new, fresh green one. All right. So let's call this, I don't know, little a. Little a. And this little b, little b. So we would be claiming from this formula here that diagonal 1 is a plus a, or 2a. So it would be half times 2a times 2b times the sine of theta. Okay? So now what? Well, let's say I just found, we have the beta up there. Let's say that I just found this one triangle over here. This one triangle's area right here, the upper one. Wouldn't that one triangle, based on the earlier formula we learned, wouldn't it be, let's do a different color, let's go blue, half AB sine of theta? Okay, great. What about this triangle's area right here? Well, that's also got A and B, and then the angle in between is 180 minus theta, which is equivalent to sine of theta when we take the sine of it. So wouldn't we have just another one of these? And then the one down here, we'd have another one, and the one down here. Wait, are these congruent then? No, they just have the same area, right? So much like if I took a triangle like this and I went over here and I found the midpoint and I connected it, because my base is the same as my base and our height is the same for both triangles, those two triangles on left and right would have been congruent. Not congruent, but equal area, okay? So now we've got 4 of these triangles. Well, what if I multiplied this by 4 times a half? I would get that the area of this is 2AB sine of theta. According to the other formula we already learned, multiplying that by 4, because there's 4 triangles all with the same area. So then if I look down here and I take this half and the 2 and I cancel it, what's left is exactly what we wrote here. And that's how we know that this formula works. And now that you've connected all of the information in your mind, that's when you want to add it to the small notebook. Because this is basically like a backup memory. It's like a flash drive for your brain. And you're going to look at it and access the files in it simply by opening it. A little bit different than maybe your flash drive for your computer, but it works very similar. It's a backup memory. And you can refresh your memory by going through it at any time. And so I don't like to add things to here until I fully understood their background information, their underlying information. So now let's go back to the other screen and let's see what happens next. I don't want that one. It says, note, now look what they wrote here. Look what they wrote. Note that for theta, we can use either AEB, the one they marked, or BEC, because AEB is equal to 180 minus BEC, and sine of theta is equal to the sine of 180 minus theta. Okay, you don't wait for them to tell you that stuff. As soon as they tell you anything, question it. In fact, that's a good piece of advice for life. No matter what anyone tells you, question it. Don't just accept what you're told. And so that's one way that you can explore these kinds of ideas. It says down below, now look what it asks. How do you think you would prove that formula? That is the writer. You should feel ashamed if you weren't asking yourself that question. The writer is once again prompting us. But what did we do? We asked and answered the question before we were prompted to do so. That is actively reading. That will build your mathematical intuition, and give you a much higher chance of getting to the AIME or the further rounds in the competition. It says, notice that it closely resembles one of the triangle area formulas. Now try to prove it. Already did so, book. Thanks. That's going to be it for this video. I just wanted to demonstrate again what that looks like and how to really build on your own. Even if those questions weren't there, we could still have done the same thing without needing the book to guide us to that process. This is also why when I tell you to go through Volume 1, I say don't just do the things that you think you need. There is so much more. Look at this passage. There is no attention drawn to it. It's just a random passage after the start of parallelograms here. So many people would be like, oh, I know what a parallelogram is. I'm just going to skip ahead to the example and try it. You're missing the joy of the book, okay? That's why when I give advice, I say cover to cover. Now, if you have a tutor you're working with who's experienced with the book and they know some passages that maybe you could just skip that or that problem, fine, great. But if you're on your own without any help, don't skip anything. You want to go through and read every single word verbatim in the text. Don't miss it. Even the end of chapter stuff is kind of interesting at times, which isn't even material to learn from. It's just historical, usually, connections to the material that you're learning. That's it for this video. If you are interested in classes as well, shoot me an email. It's on my About page, thebeautyofmath13@gmail.com. I do currently have a Volume 1 class on Saturday nights. I also have an intermediate algebra class. I have an Intro to Number Theory class that is starting in a couple of weeks. There's also going to be a Intro to Geo class and Intro to Algebra class very soon, probably by early next month, end of this month. Besides that, I think all is well here. Oh, brackets. It's time for brackets. I hope you guys are making your March Madness brackets. If you got this far, if you haven't made one or you did make one, go ahead and type in the comments what you think would be the your Final Four and your championship team pick. Good to be back. Good to see you. And I hope you're all doing well. That's the end of this one.